Are you ready to simplify? Today we're doing simplifying exponents, and they're gonna get a little bit tricky, but honestly, I think this is a lot of fun. It's like a Sudoku puzzle, and when you get it right at the end, it's all exciting, and I'm sure you guys are looking at me like I have 10 heads right now, but really it's just a set of rules that you have to follow in order to simplify big, ugly things, as you can see when you look at the examples that are coming up, especially on the back of the page. But if you go through it step by step, systematically, then it's actually quite satisfying. So, simplifying. First, let's recall some rules, okay? The exponent applies to its entire base, okay? So that is everything in the brackets. So remember, if you have something like bracket 2x all bracket cube, that is 2x times 2x times 2x, okay? If there are no brackets, then the exponent only applies to the number it is touching. So let's say that means we have 2x cubed with no brackets. That would just be 2x, 2 times x times x times x. So 3 x's, but only 1 2. Okay? Use the exponent laws with powers with the same base. And numbers still act like numbers. You might be thinking, well, duh, Mrs. Beans, like, do you think we're crazy? Well, some of you turn a little bit crazy after doing a lot of these simplifying questions, believe me. So remember, numbers are just numbers. If you have something like 9 divided by 6, you can't just say 9 minus 6 is 3. That's what people start doing, because in the exponent laws, you subtract the exponents when you divide. Remember, this is still a number. 9 divided by 6 would just be simplified to 3 over 2. Okay, you can't subtract, just subtract them. So this might seem like a weird little thing for me to say, but believe me, after teaching this for as many years as I have, I know that students will do that. Okay, so numbers are still just numbers. They haven't changed. They're not exponents. Alrighty, so let's get going with some of these examples. Okay, so you really want to take a look at an example like this. You really want to take a look at it, make sure you get to know it, become familiar with it. Look if they're same bases or not. Okay, look, there's x's on the top and the bottom, y's on the top and the bottom. So you're going to be able to simplify this quite a bit. But you always want to deal with things at the right time, or else it gets really yucky and complicated. Okay, you can still get the right answer doing this in a lot of different many different ways you can do the order. It's just some of the ways it gets really, really ugly and complicated. So notice that there's brackets on the top, but they don't apply to the denominator. So you want to simplify the numerator and the denominator separately as much as you possibly can, unless there is a bracket around the entire thing. Sometimes it helps to do that, but first we want to just simplify the numerator, okay? So 2 to the power 3. Notice everything in this bracket gets raised to the power 3, okay? So everything gets multiplied 3 times, really that's what that means, because there are brackets. So 2 to the power 3 is 8. X to the negative 3 times next, so that's x to the negative 9. And then y to the power 6, okay? And then we just rewrite the denominator the same. Okay, don't freak out that there's negative exponents. We'll deal with them at the very, very end, okay? Now we want to apply the quotient rule, okay? So 8 divided by 1, that's still just 8. So x to the negative 9, so I do minus 9 minus 3, so that's x to the minus 12. Okay, and then y is to the power 10, 6 minus negative 4. Okay, so you can leave it like this and just go on your merry way and be done. Or you can rewrite it as 8y to the 10 all divided by x to the power 12, because the negative exponent just means to flip the base, so you put that in the denominator. So there you go, isn't it pretty? See, that one's not so bad. Okay, here we have exponents and brackets on the top and on the bottom. So again, we want to simplify them each separately before we do any quotient rule business. Okay, so 27 to the 1/3. Again, you can use your calculator if you need to, but that's just the third root of 27. So that's 3. And then negative 3 times 1/3 is negative 1, so a to the power negative 1. B to the power 12, 12 times 1/3 is 4. So there you go, that's the numerator. So I just applied the 1/3 to all three of these things. Okay, now I have a half. So 16 to the power 1/2 does not give me 8. It's not 6 times 1/2. It's 6 to the power 1/2, which is the same as the square root of 16. So 16 to the 1/2 is 4. Now with these, I just, again, it's power of a power rule, so I just multiply the exponents. Negative 8 times a half, so a to the negative 4, and b to the 6. So notice the difference in how I treat a number, 16, versus an exponent like negative 8. The exponents get multiplied by a half, but the numbers, the coefficients, those are taken to the power 1/2. Okay, so in this case, that means square root. Okay, now notice 3 divided by 4, that's just the fraction 3/4, so I just leave it as a fraction, okay? Or you can turn it into 0.75 if you want to. Then a, negative 1 minus 4, that's a to the negative 5, and then b to the negative 2. Okay? Actually, what did I do? Oh yeah, sorry, I made a mistake. I was like, this doesn't seem right. 1 minus negative 4 is positive 3. 1 minus negative 4. So then it's 3a to the power 3 divided by 4b squared, because that negative exponent means to put it in the denominator. So there you go. It's a nice warm up before the big scary ones on the back. So pause the video if you need to, and rewind and watch those examples. If you're feeling a little bit right now, because it's going to get harder on the back. So make sure you understand these first, and then keep going. Okay, so now you're getting roots in the mix. So when I see roots, I like to rewrite them as rational exponents, so as fraction exponents. So I'm going to rewrite this as x to the power 8 over 5 divided by 3 to the 1/2 all to the power 3. Okay? So now I just apply my exponent laws, so power over power. So I get x to the power 24 over 5 all over 3 to the 3 over 2. And that's actually it. That's the end, because these aren't the same base, so you can't do any more exponent laws. So there's no more simplifying to be done. That's it. Okay, this one, again, I would turn these into fractions. So this one is a half, right? And this one is a quarter. To remind yourself that you're taking the half root or the square root and then the quarter root. So again, 36, that's just a number. So 36 to the 1/2, that's a square root of 36. So you get 6. But when you're getting to this power, n to the power 4, you use exponent laws, power of a power. So 4 times a half is 2, m squared. So n to the power 6 to the half is n to the power 3. Okay, 81 to the 1/4, or the 4th root of 81 is 3. This becomes m to the power 3. 12 times a quarter is 3. And n to the power 2. 8 times a quarter is 2. Okay? So now we can use further exponent laws. So first we do the numbers. So 6 times 3 is just 18. M squared times m to the power 3 is m to the power 5. You're adding the exponents. And then n also to the power 5. And that's it. It's as simplified as it can be. Dun, dun, dun. Here we go. All right. This is a bit ugly, I'm not going to lie. Notice 6, 6, and 9. So we have the same base in terms of a number on the numerator, but the denominator, it's a different base. Yuck. So we have to kind of just, we are not going to be able to simplify those totally. But there are x's and y's. We'll be able to deal with those. And notice everything is being raised to the exponent -1/3. So at some point, I need to flip this base, okay? I need to flip it like this, and I need to take everything to the third root, okay? But I'm going to deal with that later. Because if I do that now, it looks way too complicated. I'm going to make this inside look as simple as I possibly can, and then I'm going to deal with this thing out here, okay? All right, so 6x cubed quantity squared, all squared, that's 6 squared x to the power 6. So you might say, why didn't you just write 36? Well, I didn't because this 6 is still here and I want to combine the like bases later. So this is just 6y cubed all over, okay, 9 to the power 6, x to the power 6, and y to the power 6. Okay, I just left it as 9 to the power 6 because this is some huge gross number that I don't want to deal with. So I don't want to turn things into actual big numbers until I have to. Okay, especially if they're really, really large. If they're small, it's not too bad. You can change them. So this on the top will become 6 to the power 3, x to the power 6, y to the power 3. Over 9 to the power 6, x to the power 6, y to the power 6, and it's still all to the -1/3 because I haven't dealt with that yet. Okay, now I'm going to deal with what's going on here. So I get 6 to the power 3. Now 6 minus 6 is just 0, so I get x to the power 0, which is just 1. So I don't need to write anything. There's no more x values that I need to write. Okay, then I get y to the -3. All over 9 to the power 6. Okay, is that how I wrote it here? Actually, I didn't write it as y. You can write it as y to the -3, but I just put the y to the power 3 down here right away just to save time. Okay? So now at the point where I can start applying this -1/3. So I'm going to move it up here. Okay? So first I'm going to switch the numerator and the denominator. Okay, so that got rid of the negative exponent. And now I'm going to take everything to the third root. So I just multiply the exponents by 1/3. So that gives me 9 squared times y all over just 6. So that's just 81y over 6, which can be reduced to 27y over 2. I just divided them both by 3. So there you go, that's the final answer. As simple as you can. Looks a lot better than that disgusting thing. So you might want to re-watch how I did that. Notice each step that I took and why I did it in that order. Notice why I didn't turn 9 to the power 6 into a number, for instance, because later I took it to the power of 1/3, so that reduced it to a number that I could deal with a lot better. So take note of all those things. Okay, last example here. Okay, again, I want to simplify everything inside as much as possible. So my x to the power 18, that just becomes -3. Because 18 times -1/6 is -3. Now in the denominator, I'm going to write this a bit better. So it's 243 x to the 10 all to the power 1/5. Okay, notice where I put the brackets. The 243 is not being raised to the power 10, so I can't put the 10 on the outside. I can't make this 10 over 5 here and reduce it to 2 because there aren't brackets in here around the 243x all being raised to the 10. It's just that x that's being raised to the 10, but then the whole thing that's being raised to the power 1/5. And then I'll turn this into the fraction 1/2. Okay, so let me just leave the top the way it is for right now. So what does the bottom do here? What does the denominator do? Well, 243 to the power 1/5. You can do that in your calculator. That's just 3. And then this just becomes x squared, the 10 times the 1/5. Okay? Then I can apply my exponent laws, and I'm left with 1/3x to the power 5. -3 minus 2 is -5, so I write that down there. Okay, so you can leave this as a final answer because there's nothing more to really reduce, or you can write it all as one big square root, as long as you're clear that that's all under the square root. Okay? In fact, you can even reduce it to this, because the square root of 1 is just 1, so you can just apply the square root to the bottom. And there you go. So that was the note about simplifying. Really, the moral of the story is you just have to be careful and go step by step and not try to do too much in each step. That's a crucial error, is if you try to do too much at once. So just take a deep breath, do one thing at a time, be checking your steps as you go, and then you get a turn to that answer at the back and feel so good because you got it right. And that's the beauty of simplifying exponents. Thanks for watching, and I hope you learned lots.